Hey everyone, and welcome back to The Explainer. Today, we are tackling something that is absolutely crucial, but honestly, it's frequently misunderstood. We're talking about building and seamlessly connecting massive enterprise-scale systems. We're going to break down the System Development Lifecycle, the SDLC, and figure out exactly where integration fits into that puzzle. If you've ever dealt with the nightmare of mismatched software, well, you're in exactly the right place.
So let me ask you this. When is the exact right time to integrate your systems? Like, is it at the very end when all the coding is done? Think about a company building a massive commercial jet. Imagine they build the wings in one factory and the engines in another. And they don't talk. They don't share blueprints. They just say, hey, we'll wheel them both out onto the runway at the end and, bolt them together. Sounds completely terrifying, right? And yet, that is exactly the myth of write code first, connect later that plagues so many software projects.
All right, here's our roadmap for today. We'll start with 1, the integration afterthought. Then 2, meet the 4 SDLC models. After that, 3, integration across the SDLC. And finally, 4, why early planning wins. Let's dive in.
Section 1. The integration afterthought.
You know the drill. When integration is treated as just some final bolted-on step at the end, the penalties are absolutely brutal. Industry data actually shows that fixing a fundamental design flaw in production can be up to 100 times more expensive than just addressing it early on a whiteboard. I mean, you're looking at massive project delays that totally kill your time to market. The solutions end up incredibly fragile, basically held together by digital duct tape. You get scope creep, massive technical debt, and, worst of all, dangerous security vulnerabilities. Because trying to retrofit security, it's never as safe as building it in from day one.
Section 2. Meet the 4 SDLC models. First up, we've got the waterfall model. This one's your traditional sequential linear approach. It literally flows downwards phase by phase, just like a waterfall. You have to finish gathering your requirements before you design, and you have to finish designing before you code. It is very rigid, super heavy on documentation. Now, this model is absolutely brilliant for projects with stable, unchanging requirements. Think building a physical bridge, or maybe a core banking engine where the rules are just locked in stone. But it's really tough to pivot if things suddenly change. Now contrast that with Agile. While Waterfall is linear and relies on fixed upfront planning, Agile is all about flexibility. It's iterative. You work in short sprints, usually 1 to 4 weeks, and you rely heavily on continuous customer feedback. You're constantly delivering working pieces of software and just adjusting on the fly. It's basically perfect for projects where the business needs are evolving rapidly.
Rounding out our 4 models, we have Spiral and DevOps. Spiral is kind of fascinating because it's a heavily risk-driven process. It mixes the structured nature of waterfall with iterative prototyping. You literally spiral outward, doing continuous risk analysis at every single loop, which makes it ideal for those massive, high-risk, complex projects. Then we have DevOps. DevOps bridges that historical gap between software development and IT operations. It relies intensely on automation, continuous integration, and continuous delivery, which allows teams to push highly reliable code to production at, frankly, blistering speeds.
Moving on to Section 3, integration across the SDLC. So integration isn't just a box you check at the end of the line. It continuously orbits the entire SDLC. Just like an aircraft's comm systems are constantly talking to the control tower, the engines, and the nav systems throughout the whole flight, integration is a continuous discipline that spans the entire life cycle. Let's break down the 6 distinct chronological phases of the SDLC where these integration activities absolutely have to happen. We've got requirements gathering, design, development, testing, deployment, and finally, maintenance and operations. Let's walk through exactly what integration looks like in each one.
Phase 1, requirements gathering. Long before a single line of code is written, a system architect has to ask some crucial questions. Like, what existing systems are we actually going to interact with? Is it a legacy CRM? Some cloud-based HR tool? You need to map out the exact data flows. What data moves where, how often, and at what volume. And don't forget the non-functional requirements here, like security and scalability. If a partner system goes offline, does your system gracefully degrade, or does the whole thing just crash? You gotta map that out right now.
Next up, the design phase. This is where you create the actual blueprint for connection. You're not coding yet, but you are picking your integration architecture style, maybe an enterprise service bus or an API gateway. You define your standardized data schemas, you design the APIs, and crucially, you design your error handling and security protocols. Basically, you're deciding right here exactly how these totally distinct systems will securely shake hands.
Then we hit development and testing.
Here, developers are actually building those connectors and APIs, ideally as modular, reusable pieces. They're using continuous integration, or CI, meaning code from different devs is merged and tested constantly to catch conflicts early. And look, testing isn't just clicking a button to see if it works. We're talking unit testing the isolated components, integration testing the connections between systems, and user acceptance testing to make sure the whole end-to-end business process flows seamlessly across all your connected platforms.
Finally, we cross the SDLC finish line into deployment and maintenance. Actually, scratch that. Finish line is kind of misleading. Deployment means safely pushing this to live environments using automated pipelines and having a very strict rollback plan just in case things go sideways. But the job isn't over. In the maintenance and operations phase, you are proactively monitoring those connections for errors or latency. You're managing interface changes as external systems update, and you're continually optimizing those data flows as business needs evolve over time.
Section 4. Why early planning wins.
When you stack these two approaches side by side, the contrast is stark. Waiting for late integration just penalizes you with massive costs, frustrating delays, and critical security gaps. But early integration planning, that gives you proactive problem solving. You spot the mismatched data formats before they're ever coded. You get highly accurate project estimates because you actually understand the full scope. And ultimately, you get a much faster time to market because you aren't stuck fixing catastrophic comms failures at the very last minute.
If there is one recurring drumbeat you take away from this explainer today, let it be this. Integration is not a single event. It is continuous. It's an ongoing discipline that keeps enterprise systems safely coordinated, secure, and functioning as one unified whole.
Actually, this source material perfectly summarizes this whole idea with a great quote. Integration is not a standalone activity performed at the end of a project, it's an ongoing concern woven into almost every phase. It literally has to be in the DNA of your project from day one.
So I'll leave you with this provocative question to chew on. Think about the system architectures currently being designed in your own organization. Is your next project waiting until the runway to see if the pieces fit together? Or are you designing for seamless flight from the very first blueprint? Thank you so much for joining me for this explainer. Keep learning, keep planning early, and I'll catch you next time.